Welcome to this lecture on process control Laplace transform. So in this class, we'll solve a problem related to forcing functions. This problem involves a combination of step function and ramp function. So we have seen earlier step function, we have seen ramp function, we have also seen terminated ramp function. So this is a combination of all step function and a ramp function which is terminated ramp function, we can say. So the question starts with Laplace transform. The Laplace transform of a function is given. A forcing function has the Laplace transform given by this f of s equal to 1 by s plus e power minus s minus e power minus 2s by s square minus e power minus 3s by s. So we have to find, we have to sketch the function f of t, which means first we have to find the Laplace transform, inverse Laplace transform of this, and then draw a sketch of f of t. So let us find out what is the inverse Laplace transform. So if we take inverse Laplace, 1 by s is 1, that is u of t. And here there are two terms, e power minus s by s square. 1 by s square is t, multiplied by e power minus s is translation of function, so t minus 1. So t minus 1 is the inverse of e power minus s, this term, e power minus s by s square. Then similarly e power minus 2s, this term minus 2s by s square is same t, translation of the function t minus 2. And the last term e power minus 3s by s, 1 by s is u of t, and e power minus 3s means function is translated, shifted by 3. So this is the inverse Laplace of the given function. Now we have to sketch this. Well, this is the equation and you have to plot this, make a sketch of this. First one is f of t equal to, same, f of t equal to ut is printed here. Ut means unit step function. This is u of t. You have to imagine vertical. So this u of t goes till 1. So you have to think as perfectly verticals and perfect horizontals, please. Then at t equal to 1, what happens? There is a straight line. T minus 1 is the equation of a straight line of slope 1. So there is a straight line of slope 1. This goes up to 2. It's not up to yes. So this t minus 1 is superimposed on this u of t. This is t minus 1. Then these two, t minus 1 minus t minus 2, indicates that this is going to be a terminated ramp. This difference of two linear functions indicate that it is going to be terminated here at t equal to 2. This terminated ramp function I have discussed in my previous lecture. So you can refer to the lecture which is named as PC28. You can refer to the video PC28, where terminated ramp function and its equation was discussed in detail. So these two difference of two linear functions indicate that this is going to be a terminated ramp. It is going to be terminated at 2. It is going to be terminated at 2. And it is terminated, so it becomes a constant value till 3. Till 3 it is constant value. Okay. Then at 3 what happens is there is a step function of magnitude -1. T minus 3 means at t equal to 3 there is a step function u of t of magnitude -1. That means it is going to decrease by a magnitude of 1. From 2 it is jumps down to 1. Jumps down to 1. And afterwards jumps down to 1 and it is constant afterwards. So this is the sketch u of t starting from 0. I have taken 0 on the x-axis, time axis here. This is the time axis. This is function f. On the y-axis, function axis, I have taken this as 0, and for t-axis, I have taken slightly shifted 0 for clarity. So this is 0. U of t start here. It goes as unit step function till 1. Till 1. Then afterwards, it is superimposed with a linear function or ramp function t minus 1, which goes up to 2. Which goes up to 2. Then at 2 it is terminated. At 2 it is terminated. So once it is terminated, it is some constant value. And at 3 there is a step down function, step function of magnitude -1. So magnitude decreases from 2 to 1 suddenly at 3. So this is a graph. The same function, the same sketch I have drawn here neatly, because here lines were not vertical, lines were not straight, lines were not horizontal here. So I had drawn neatly somehow to scale with perfect horizontals and verticals and perfect straight lines. So this is u of t here. Then plus t minus 1. This is plus t minus 1. Same, this one. Then minus t minus 2. That means it is terminated here at 2. It is terminated at 2. It goes on till 3. And at 3 there is a downward step function. I hope you have understood these equations and this sketch. So I had explained the complete sketch, all the 3 parts, 4 parts, 1, 2, 3 and 4. Now I will try to explain the same graph, same sketch by different ways also, another ways, alternate methods, alternate ways. Okay, let me take this u of t is there's only one, u of t is u of t. Then to that, if we take up to this u of t plus t minus 1. Okay. So u of t is this. If it is not modified at t equal to 1, it will continue to go like this, right? It will continue to go like this. But what happens here? At 1, this graph is superimposed, t minus 1. So if we impose t minus 1 on this, it becomes like this. That's what I told earlier. Now I'll give another way of explaining this, understanding this. What is t minus 1? You may be wondering why this is t minus 1. This curve, this straight line is added to this. But t minus 1 is this. T minus 1 is a straight line of slope 1 passing through 1. Okay. Straight line of slope 1 passing through 1 is t minus 1. Okay, so I'm trying to explain this ut plus t minus 1 first. this 2 by another method. So this is u of t till point 1, and this u of t plus t minus 1 means I can split this as u of, okay, and that is another method. We'll come to that later. Right now, okay, so this is u of t, and t minus 1 is this straight line. This straight line AF. AF is a straight line t minus 1. AF, the equation for AF is t minus 1. You can check the straight line of slope 1 passing through this point 1, passing through point A. A is, the value of A x-axis is 1. So AF is t minus 1. AF and its extension is t minus 1. So to this u of t, this line, this t minus 1 has to be added. So if you add this, if you shift this guy, if you shift this line t minus 1 same way parallelly and place it here, you will get this CE. Okay, if you shift this AC, if you shift this AC, this equation AC, this as equation of this line is t minus 1. If I shift this AC same way parallel to this, keep moving this AC and place it on C, is going to be this C. AC and AF and CE are parallel. So if you shift this parallel line t minus 1 and add to this C, you'll get this. Okay, anyway, that is one way. The other way is to u of t I have to add t minus 1. What is t minus 1? T minus 1 is at any point t, consider any point t corresponding to point B. What is the value of f here? Function f. The value of function f is here is bf, right? This is a function t minus 1. The value of t minus 1 from graph is this point bf. At any time t between 1 and 2, at any time t between 1 and 2, the value of this graph, the value of this straight line from the graph is this line bf. Bf is t minus 1 because it is f is a point on this straight line. Now if you look at this graph triangle ABF and CDE, from these two triangles, they are similar triangles, you can check, you can easily understand that DE you can understand that DE by CD will be equal to DB by AB, right? You can see DE by CD will be equal to DB by AB. But CD and AB are equal, even though in the graph it doesn't look like, because it is not drawn to scale. If you draw to scale, you'll know that CD and CD, these two are equal. CD equal to AB, CD and equal to AB, and both are equal to t minus 1. Both are equal to t minus 1. Both are equal to t minus 1. So what will be, therefore, D also equal to dB. Oh, I made a mistake. No, this is DE by CD. I made a mistake here. DE by CD should be equal to not dB but FB. Okay. It's not dB but FB. I correct it. DE by CD should be equal to FB by AB. Right? So since CD equal to AB, that means DE will be equal to FB. DE will be equal to FB. DE will be equal to FB. And what is FB? If you look at the figure, FB is a point on this line t minus 1. So FB equal to t minus 1. So DE also equal to t minus 1. So DE equal to t minus 1. So from this unit step function, from this value, DE is added. DE is added means t minus 1 is added. DE is added means t minus 1 is added. So that is what ut plus t minus 1. From the graph, it is u of t1 plus DE, and DE is t minus 1. So ut plus t minus 1 therefore is represented by point E at any time t greater than 1 and less than 2. It's clear. So ut plus t minus 1 by this way, this is u of t and DE is t minus 1. DE is t minus 1. So you get this line. So this is another way of understanding how this line CE is getting added to this ut to get this equation, or how this equation reverse. We want to sketch this equation. How this u of t plus t minus 1 look in the graph. This is u of t, this is t minus 1. Either you can shift t minus 1 parallelly and impose on this, done. Or by this way, t minus 1 is getting added. T minus 1 is this, and this is also t minus 1. This is also t minus 1 getting added to u of t. Okay. This is t minus 1. Same way, from u of t, this is also t minus 1 getting added from ut to t minus 1. So that gives this curve. Now let us come to this t minus 1 minus t minus 2. There's a terminated ramp input. It stops here. So how do I plot? How do I make it that t minus 1 minus t minus 2 means is going to stop here, because this 2 indicates it has to be stopped here, t minus 2. So let us see this now. Now let us take these three equations. See how do I plot these three? This is another method of adding this or subtracting this t minus 2. Now if you look at this equation, line CE, what will be the equation of CE? For easy understanding, let me erase all these lines which I described for the previous method. 1 minute. Yes, if you look at this line, straight line CE, this is up to this, from here to CE up to this u of t minus plus t minus 1. Explained already. Now what will be the equation of the straight line CE? It passes through this point 1 here. Y-axis is also 1, x-axis is also 1. And y-axis is 2, x-axis is also 2. It passes through this point 1, 1 and 2, 2. So if you check this equation, you will find that the equation of CE is nothing but simply t. The equation of CE is t. Equation for CE is t. Now from this line, from this curve, that is these two, u of t plus t minus 1, that is starting from here and going here. So if you leave it, it will keep on going like this, right? Now what do I do here is, I can write it as here u of t plus t minus 1. That is the first two curves. Then this I'll split minus t plus 2. I'll split this as minus t plus 2. That means from this line, I remove minus t. I remove t. I subtract t, or remove t. This itself is t. And from this I remove t again. What will happen? From this value, afterwards, if I do this, the value will become 0. It will come to 0. Right? So this plus this minus t will give me 0. To that you add 2. If I add 2 again, that means I go back to this 2. From 0 I go back to this 2. So first I remove this t, it goes to 0. And then I add this 2, it goes to here. So these are only value addition. Okay, numerical additions, not the behavior of functions. Behavior of function is like this. This does not mean remove t and add 2 means does not mean that the function comes to 0 and then goes back to 2. It's not like that. So if I remove t from this, t minus t will be 0, and to that you add 2, I'll get this. So that's all. And again add 3, now minus u of t minus 3. That is simple. That is only one way of explaining. There is a decrease in magnitude. So you get this. So this is our complete function now. I hope it is understood. So let me remove all these construction lines, then it'll be easy for you to follow. So what I have drawn by this green line is a function now. This is this u of t. Then at 1 it stops. This is 1. 1 it stops. Then it goes by a ramp, and that ramp function is stopped at 2, terminated 2, terminated constant line. Then a step function of magnitude -1. So this is a function. Well, now the same figure I draw neatly, same equation, same sketch. This is whatever I explained here. This may not be to scale, and not exactly horizontals and not exactly verticals and straight lines. So I try to sketch it using perfect verticals and perfect horizontals and straight lines. So u of t at 0 plus t minus 1 minus t minus 2 terminated at 2, then at 3 step down magnitude. Okay, so this is another way of explaining these functions. First method, what I discussed in the beginning, was easy to remember, simple, and this is using exact values showing graphs. Okay, so now another point, this we have 1, 2, 3, 4 terms. These 4 terms, each term will have applicability only during certain period. For example, u of t is applicable only between 0 and 1. Okay, so if you see here, so it will be equal to u of t for t less than 1. And the next term, if you add the next term, u of t plus t minus 1, this is applicable for t between 1 and 2. T minus 1. If you add the third term, u of t plus t minus 1 minus t minus 2. So this is applicable only between, well, this you can take t less than 2. Okay, this less than 1 doesn't matter. You can write up to t less than 2. This is applicable. And this is applicable for t less than 3. And for t more than 3, all equations, all the 4 terms. So this is for t more than 3. So depending on the time period. So what is the difference between this written in this form and written in this form? You'll find that these 2 terms added extra. That is these 2 terms. These 2 terms, this was not there before here, and similarly this was not there. So these 2 terms I added. So when you add this, when you include, sorry, not added means included. When you include these 2 terms, this equation becomes applicable for the entire range. Whatever be the range. How? What is the meaning of u of t minus 1? This u of t minus 1, u of t minus 1 has got value only when t is greater than 1. So u of t minus 1 will have 1, will be equal to 1 only when t greater than 1. If t is less than 1, the value of this function is 0. U of t minus 1. I'm talking about u of t minus 1 will be 0 for t less than 1. Will be equal to 1 for t greater than 1. Similarly, this u of t, this value will be equal to 1 for t greater than 2. For if t is less than 2, this value will be 0. So you take any period t less than 2, you will have only this term, first, second, that's all. For t less than 2, we'll have only the first term and second term, because this is 0 and this also will be 0. U of t minus 3 is what? U of t minus 3 will be equal to 1. Same way, u of t minus 3 will be equal to 1 if t is greater than 3. If t is less than 3, this value will be 0. So if we take a period t less than 2, this term is 0, this term is 0. So you are left with only first two terms, u of t minus 1. So that is what, t less than 2, this equation. For t less than 2, we will have this equation. T less than 2, first two terms. Similarly, when t is less than 3, this term becomes 0, this becomes 1, so this also becomes 1. So you'll have first term and t minus 1 and t minus 2. When t less than 3, these three terms. When t equal to greater than 3, this is also 1, this is also 1, this is also 1. So you have all the terms, this equation. Okay, so this is a general form of writing this function so that it is applicable for any period of time greater than 0. So this equation applies for any value of t greater than 0, this equation. So I hope you have understood this combination of step, ramp, terminated ramp, and then another step function. So starting with step function and ending with step function, in between a terminated ramp. So hope you had followed this, and if you have any doubts you can ask in the comment section. And also I request you to kindly subscribe to this channel so that you'll get notified of my future lectures. So we'll be doing more theory part and more problems in the coming days. So please stand by for those lectures. See you till then.